This is the third part of your Asian portion tutorial, and here I've got a little sum ready. This again is from the 2012 paper, that means this year's paper, and this it's a 3-mark question, and the question number is 1 part B. So you could imagine that when you get the paper, this one's staring you in the face right over there. So just imagine the horror if you don't get this sum at all. That's why I'm going to be solving it right now. These are type of questions that you can expect, sort of word problems on ratio and proportion, and they've got nothing to do with component or dividend. It's simple ratio. The monthly pocket money of Ravi and Sanjeev are in the ratio 5:7. Their expenditures in the ratio 3:5. If each saves rupees 80 every month, find their monthly pocket money. It's fair enough. You've been given that pocket money is 5:7. So you could write this as 5x upon 7x. Why you can write it like this is because x will be any number. Say your x is 3. That means their pocket monies will be 15 and 21. So your ratio will be 5:7. So it's basically a variable. You don't know how much it is. Now that could be 4 as well. So then your pocket monies would be 20 and 28. It could be 100 as well. So your pocket monies would be 500 and 700. So this is a variable over here. Same way, we'll make a variable for expenditure. So let's make it 3y upon 5y. So this is Ravi over here, this is Sanjeev. Now you've been given both of them save 80 every month. What is the value of how much they save? That's basically income minus what you spend. So 5x minus 3y. We're going to take both the people separately. 5x minus 3y, this is Ravi, is equal to 18. You've been given that. Similarly, 7x minus 5y is also equal to 18. Now, there are many ways to do this sum, but I'm just going to go through the way that I did it. Now here you have two linear equations, you have two variables, you can solve this pretty easily. But I think the better way to do it would be like this. You know that both of these are equal to 80, which means that this is equal to this. Just write that down. 5x minus 3y is equal to 7x minus 5y. And as always, take both the x's to one side, the y's to one side. So let's get the x's here. So that becomes 2x. Get this y here. So it's equal to 2y. Cut x is equal to y. So now let's just take any one of these equations. Let's take the first one. It has smaller numbers here. And replace the value of y. Now y is equal to x. You could also write this as 5x minus 3x is equal to 80. That means 2x equal to 80. That means that x is equal to 40. And since y is equal to x, y is also equal to 40. You could verify this with the second equation as well. So you'll get 7x minus 5x is equal to 80, which is 2x equal to 80. Again, x is equal to 40. And all they ask you to do is find their monthly pocket money. Now their monthly pocket money, the first guy is 5x, second guy is 7x. Now you know x is 40, so just multiply. So you get 200 and 280. If you really want, you can verify your values as well. You've been given that x is equal to y, so you could write the expenditures over here as 3x upon 5x. So multiply and you'll get that the expenditures are 120 and 200. And each of them saves 80. Just look at the differences. The first guy earns 200 and he gets rid of 120, so he saved 80. Similarly, the second guy also has 80 here. So it's confirmed that your answer is correct. So you really don't need to do it, but if you're not confident, I think you should. It takes no more than a minute. Um, so, so I'm going to do one more question. It's another type of question that you may be asked. So you'll see these type of questions a lot. One minute. Yeah. So what this question asks you is, there are 36 members in a student council, and the ratio of boys is to girls originally, right? B is to G is equal to 3 is to 1. By the way, this question is from the Together With book, so that's what I'm referring. That's the book I'm referring to over here. So it's given as 3 is to 1, and it asks you how many more girls need to be added so the ratio becomes 9 is to 5. So only looking at how many more should be added to this. Now you've been given total number and you've been given the ratio, and you can see it's divided into 4 parts. So divide 36 by 4 and you get 9. So the 9 girls and 27 boys, and this is originally. So what it's asking you is that how many need to be added to this number. You could say it's x, so that the ratio becomes 9 is to 5. So this is your equation basically. Cross multiply and solve for x. 27 into 5 becomes, what does it become? 135. Yeah, 135 is equal to 81 plus 9x. So take your 81 to the other side and you get 54 is equal to 9x. Divide 54 by 9. That's not an x. And you get x is equal to 6. Again, you can check your answer yourself by just substituting. Add 6 to the 9 and you get 15. So 27.15 cut by 3 and you get 9 by 5. So you could say your answer is correct by just substituting over there. And you're also going to get problems based on work. So one such example I'm going to do right now. It's very unlikely that you'll get a problem on work in this chapter. If you do get it, you'll get it under quadratic equations. But I'm doing it just in case because I know for a fact that even I struggled with those. So, so the question again, it's from Together With. The work done by x minus 3 men in 2x plus 1. What is this? Hold on a second. Yeah, that's it. In 2x plus 1 days. 2x plus 1 days. And work done by 2x plus 1 men in x plus 4 days is in the ratio of 3 is to 10. Okay, just imagine two groups of people. One has x minus 3 people, one has 2x plus 1 people, and they both work for different number of days. That's this and this. And the work that they're able to do is in the ratio of 3 upon 10. So say you have one man and the work that he does in one day, just let it be any variable, just say W for now. It's actually a constant, not a variable, but whatever, you get the point right now. And now you have x minus 3 men. Instead of one man, you have x minus 3 men. So we're going to multiply this value by x minus 3, and this is work done by one man, fine, in one day. But here we have 2x plus 1 day. So we're going to multiply this over here again. And we're going to do the same thing at the bottom in the denominator, except we're going to use 2x plus 1 into x plus 4. So this is basically your equation is equal to 3 by 10. Now you can see the reason why they give you 2x plus 1 here and 2x plus 1 here. It's because it would cancel pretty easily, and you can cut these as well. You can ignore these completely. So the equation you're left with is x minus 3 upon x plus 4 is equal to 3 by 10. Just cross multiply everything. You get 3x plus 12 is equal to 10x minus 30. Take the x's on one side, so 7x is equal to 42, is it? Yeah, 42. So x is equal to 6. Now here we've been asked to just find the value of x, but say we had to find the number of days taken by the first group or something like that. All you do is just substitute the value. So here, if you substitute, you'll get 13. If you want to know number of men over here, that'll be 3. Number of days taken by this group would be 10. So you could substitute if they ask you to find anything like that. And there are many other word problems that they ask, but the most common type of questions that will be asked from this chapter is basically proving. They'll give you something to prove, and you need to use something called the K method. K method, I'm going to rub this out first. It's not really something that I can teach you. It's just something I can show you how to do it. As the name suggests, it's just a method. It's not really a concept or anything. So it's called K because you equate a few ratios or just one ratio, however the question demands you to a variable. It's a constant actually, not a variable, called K. So I can give you an example of say x upon a is equal to y upon b is equal to z upon c, and this whole thing is equal to k. So now if you look at x is actually equal to ak, y is actually equal to bk, z is equal to ck, and so on. You could go on like that. And now if a question asks you to prove just anything, just assume it's something for now, all you need to do is take the x's, take the y's, take the z's, and eliminate them. Eliminate them how? By replacing them with values like ak, bk, ck. And when you do that, you're going to be left with just a, b, c. And you're most likely to get the result like that, because then everything will get cut, and you're eliminating all these three. You're actually halving the number of variables you have, and in most cases the k will get cut, which is the whole purpose of this method. And I can't really give you any definite rules for this whole method, because it depends from question to question. But the main thing is equate this whole thing to k. Just cross multiply it to get the value of the numerator. So x equal to ak, y is equal to bk, z is equal to ck. And then, as I told you, you could choose x, y, z, just replace all the x, y, z with those values. And then as the question goes along, I think you'll see for yourself once you do the questions that it becomes pretty obvious where you need to put what. So again, the only way to master this method is to do a few questions on it. And I'm pretty sure there are many in your textbook, and if not, you can always get these other books. uh, but by no means should you leave this whole method out. And also note that this is just a method, it's not really a concept or anything. So it's just a simpler way of doing it. You can prove all those questions without using the K method. It just becomes long and tedious. This is just a shortcut, and I think if you know this much, you should be fine. And keep replacing the X, Y, Z's, and automatically you'll see what you need to do where. And of course, if you have any doubt and any question, you can contact us or any one of your teachers. I'm pretty sure they'll help you out as well. So that's it for this chapter. It's a short chapter theory-wise. There's not much to learn. Just component, dividend, basic ratio, and this K method. Um, After that, if you know all these, um, you're most probably going to get a full in your ratio proportion questions. So that's it. And the next chapter I think will be factorization or factor theorem. Sorry, the factor theorem, not factorization. So we're going to continue this now.